So now that we've talked about measures of central tendency and measures of dispersion in 3.1, 3.2, and 3.3, in 3.4 we're going to look at measures of position and outliers. So the first thing we want to talk about is the z-score. So in general, that tells us how many standard deviations a data value is away from the mean. And that's calculated by subtracting the mean from the data value and then dividing that by the standard deviation. A z-score is unitless, and it has a mean of 0 and a standard deviation of 1, which will be extremely important later on in this course, so you may want to write that down, keep it on a note card, keep it in your mind or very close. So some formulas for z-score. So in general, z is equal to the data value minus the mean over standard deviation. So you'll see the population z-score. Z is equal to x minus mu over sigma. And then sample z is equal to x minus x bar over s. So I'll go through this example later on. So in general, make sure you read the problem. Sometimes you're going to want the smaller z-score, sometimes the larger. You really want to read into context. So if you're talking about a baby that weighs relatively less, you want a smaller z-score. If you're talking about a baby that weighs more, you want a larger. If you're talking about a more convincing victory in a race, you want the one that has a smaller z-score because that's further away from the mean. That means they finished in less time. So just pay really close attention to the problems that you're actually looking at. So the next thing we have is the percentile. So that's just saying that the kth percentile here of a set of data is a value such that k% of the observations are less than or equal to that value. So the key phrases here are less than or equal to the value. So you've probably seen these test results. Your kids have gotten tests back. You've taken EOGs, EOCs, SATs, tests like that, and it said you scored at the, I don't know, let's go with the 75th percentile. So that means that 75% of the people taking the test had the same score as you or scored less. So there was only 25% that scored higher. So that's what percentiles actually mean there. So we'll go into that in more detail in a minute. Quartiles. So a specific type of percentile. So it divides your data set into fours. So the first quartile is denoted Q sub 1. And it divides the bottom 25% of the data from the top 25. So it's equivalent to the 25th percentile. The second quartile splits it right in half, so it's the 50th percentile. And that's the same thing as the median. And then we have the third quartile that divides the bottom 75% of the data from the top 25% of the data, and that's the 75th percentile. So we can find them by hand. We're going to do those in the calculator as well. You can go through this if you would like. And then inner quartile range is the range of the middle 50% of the observations in the data set, and it is just Q3 minus Q1. So simple calculation there, and we'll go through how to interpret it in a little bit with an example. So suppose we have an additional car that goes through this, flying through this construction zone at 100 miles an hour. How does that impact the mean, median, standard deviation, and quartile range? So again, you can see significant impact on the mean, not so much on the median. Significant impact on standard deviation, not so much on IQR. So again, this goes back to that resistance. So again, the median and IQR are resistant, but mean and standard deviation are not. So mean and standard deviation go together, median and IQR. So you can kind of see the relationship here. So we use the mean to calculate standard deviation. Median is kind of used in the calculating IQR. We think about what we're actually looking at when we calculate Q1 and Q3 is the median of the bottom half and the median of the upper half. So we're using median to calculate IQR. So median and IQR go together, mean and standard deviation. So that's how those two are related there. So if we have a distribution that's symmetric, we want to use the mean and standard deviation to report central tendency and dispersion, and if we have a distribution that's skewed either left or right, we want to use the median and interquartile range to describe that. So that sums up 3.4.